Welcome to qnawire.
We're given this disk attached to an arm ABC, and we need to find what the angular momentum is about the point A. So in order to solve this problem, we need to first find what the angular momentum is about the point C, and then also find what the distance is between point A, point C, and then also find what the velocity is about the mass center. So I'll start by writing out the equation for the angular velocity in terms of vectors, in terms of a vector. So this angular velocity omega, that's going to be equal to omega 1I should be omega 1j plus omega 2k. And the way that I found these directions of the angular velocities is that we use the right-hand rule to know what direction that the angular velocities are going. So we can then write the angular velocity vector as 5j plus 15k radians per second. So next we'll write out the equations for the different components of the moments of inertia about the disk. So for the x component, that's going to be equal to 1 over 4 mr squared. And we know what the mass is, and we know what the radius is as given by the problem. So we plug in the mass, and then we plug in the radius. So this radius is in meters. And we'll get a moment of inertia of 0.0225 kilogram meters squared. And now for the y component. The y component is going to be 1 over 2 times mr squared. So the y component is actually going to be 1 over 4 mr squared, since the x component and the y component use the same formula. And because of that, we know that I of y is just going to be equal to I of x, which is equal to 0.0225 kilogram meters squared. Now for the z component, so this z component, this one's going to be equal to 1 over 2 mr squared. So I of z is equal to 1 over 2 times the mass times the radius in meters squared. And we'll get a moment of inertia is equal to 0.045 kilogram meters squared. So now to find the angular momentum about the point C, this is equal to I of x times omega xi plus I of y times omega yj plus I of z times omega zk. So we can plug in the calculated values. So we plug in I of x, then we plug in omega x, then we plug in I of y, and then omega y, and then I of z, and then omega z. And this will give us a vector of the angular momentum about the point C. That's equal to 0.1125 J plus 0.675 K kilogram meters squared. So now that we know this angular momentum, we next have to find the distance between point A, and point C. So that distance, which I'll call R, so that distance R, it's going to be equal to 0.450I plus 0.225J. And this is just by looking at the free body diagram. And next we're going to find the velocity about the mass center. So that velocity is going to be equal to the angular velocity omega 1 times the r vector. So v is equal to 5 times the r vector. And we're going to be left with negative 2.25 k meters per second. So we now have all we need to calculate the angular momentum about the point A. Since this angular momentum is going to be equal to the angular momentum about the point C plus the r vector cross m times b, the v vector. So now we plug everything in. So we plug in h of c. So the I component plus the k component. So the j component plus the k component. And then plus the r vector cross the mass times the velocity vector. And then doing all the calculations, we'll get a final vector for the angular momentum about the point A that's equal to negative 2.03I plus 4.16J plus 0.675K kilogram meters squared.